transitioning now from work that's accomplished, remember no work accomplished here because it didn't move, D, distance is a term for this sort of work, to energy that's expended. Energy actually then, there's all sorts of different forms of energy. We'll be kind of talking a little bit about that, but energy in general is either stored and capable of doing work, or it's being expended, i.e. it's being spent in the process of doing work. It's one good solid definition of energy. So one of the things then in this definition is we have stored energy. It's called potential energy. The abbreviation for potential energy is PE, and kinetic energy is energy being spent. So potential energy is energy stored, kinetic energy is energy being spent. Kinetic energy oftentimes is associated with motion. The units for energy are the same as the units for work. And we said the units for work was the joule, and the joule could be broken down into newtons per meter, newton meters, excuse me, and the joule can also be broken down to kilograms meters squared per second squared. This might help you in some problems later on. So the amount of work accomplished will be equal to the amount of energy expended. Seems reasonable. Now this feels like a deja vu. This is the exact same slide we looked at earlier with this guy exerting a force over a distance d. The force is 2.5 newtons and the distance is 6.12 meters. We could ask how much work was expended. We could also ask how much energy was expended. So work is equal to force times distance, and the energy is also equal to force times distance. So let's go ahead and knock this out again. Energy is equal to that 2.5 newtons times 6.12 meters. We're going to round it, remember, to 2 decimal places. This was that 30, wasn't it? No. Huh? So my calculator spits back 15.3, and I'm going to round it to 15. Oops. I'm going to round it to 15. Final answer. 15 units of energy are the same as units of work. Units are going to be joules. Let's knock out this one. Same thing. Remember we said now energy is equal to force times distance. In this case, energy is equal to 2.3 times 10 to the negative 6th newtons times the distance. In this case is 6.12 meters. 2.3, hit my EE key, negative 6 times 6.12. I get 1.4076 times 10 to the minus 5th. I'm going to round it to 2 digits. I'm going to get 1.4 times 10 to the negative 5th. And remember we said units of energy are the same as units of work, and those units will be joules. So this one actually was a quiz question before. I'm not going to make a quiz question this time, but hopefully before you got work, in this case of applying a force 2.5 newtons for 12 meters, you got work as force times distance, or 30 joules. So also energy expended is 30 joules.